All right, this is the next lesson in geometry. It is called arcs and chords. Now, we've talked about each of these before. We're going to go into more detail today. Just to refresh your memory, recall that a chord is a segment with endpoints on the circle. That's a chord. Okay, it's a segment. So, for example, AB is a chord. Segment AB. Chord is a segment. Okay, and we call that an arc is a part of a circle. Okay. Okay, so we did chords in the first lesson, and we did arcs in the second lesson. Okay. Here's the first theorem for today. In a circle or in congruent circles, so in one circle and two circles that are exactly the same size, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay, so remember, if and only if, it means you can read it both ways. Okay, it can go each way. If and only if, a biconditional. So if you knew that the two chords were congruent, so let's say you knew that chord AB, if this chord was congruent to chord CD, then it means that you can conclude that arc AB is congruent to arc CD. Okay? And the other way is true as well. Suppose you knew that arc AB was congruent to arc CD, then you can conclude that segment AB, that chord, is congruent to segment CD, that chord. Okay? Goes both ways. So that's the first theorem for today. All right. Okay, moving on. Okay, the chords of adjacent arcs can form a polygon. We did polygons earlier. Yeah, we did polygons already. In the figure below, quadrilateral ABCD is an inscribed polygon. That's what it's called. Quadrilateral ABCD, that's called an inscribed polygon because all of its vertices lie on the circle. So anytime you have a polygon, no matter what shape it is, it could be a triangle, it could be a square, it could be a rectangle, it could be a pentagon, it could be a hexagon. If all the vertices lie on the circle, then it's called an inscribed polygon. Okay? Circle E is circumscribed about the polygon because it contains all the vertices of the polygon. Okay, so quadrilateral ABCD, all of those vertices lie on the circle, so that means it's inscribed in the circle. And since the circle contains all the vertices of that quadrilateral, then ABCD is circumscribed about the quadrilateral. Okay, that's just some terminology you need to know. Start off with a nice, easy example on arcs and chords. Okay, find the value of x. So you can see the arcs. This arc is labeled as being congruent to this arc. So it means that the chords are congruent. Okay, the chords that form those arcs, they have to be congruent. That's from the theorem on the first page. Okay. Since you know the minor arcs are congruent, then it means that the chords are congruent. So I'm going to say 2x minus 12 equals 36. So 2x equals 48. x equals 24. Okay. That was pretty easy. This problem is a little more difficult. Find the value of x. Okay, so think about it like this. Okay, you have the two chords labeled being congruent. So chord SU is congruent to chord ST. Therefore, the minor arcs associated with them are congruent. So it means that if this arc ST is X, then it means that arc SU can also be represented by X. And you should know that all the arcs add up to 360. So I'm going to say X plus 38 equals 360. Solve that for X. Okay. Combine like terms, 2X plus 38 equals 360. Subtract 38. 2X equals 1. 2X equals 322. X is going to be really big. I mean, you can probably tell that from the beginning. X equals 161. That's good. If you want to do a quick double check, you can do 161 plus 161 plus 38, and you'll see it does equal 360, so that one's good. Okay. On to example 3. So this one looks hard, but it's really not, okay? Look at chord RQ and chord MP. Those are congruent, so the chords are congruent. So it means their intercepted arcs are congruent. So if arc MP, I'll write down MP is congruent to RQ. Those chords are congruent because those arcs are congruent because the chords are congruent. So it means that the measure of arc MP equals the measure of arc RQ. So it means that the measure of arc RQ equals 67. Now, since this arc is 67, yesterday we talked about central angles being congruent to the intercepted arcs. So if arc RQ is 67, then the central angle that corresponds to that, in this case x, also equals 67. Okay? Central angles equal the arcs they intercept. Okay. So those were the two easier pages. These next two pages are going to be a little more difficult. Okay? In a circle, if a diameter or a radius is perpendicular to a chord, then it bisects the chord and its arc. Okay? So if you look at this diagram right here, you have diameter BA and you have radius CA. You can use either one. You have that being perpendicular to TV. Okay? You see you have that right angle right there. So since the diameter and or the radius is perpendicular to chord TV, then it means it bisects the chord and its arc. So it means that TU is congruent to UV. Okay? And it means that arc TA is congruent to arc AV by extension. Okay? Okay, here we go. Example 4. Circle O has a radius of 13 inches. Okay. Radius OB is perpendicular to chord CD. So what that means is it bisects chord CD. So I'll just label that. This is congruent to that. That's from the theorem right above. It says chord CD is 24 inches long, okay? Also, the measure of arc CD equals 134. Find the measure of arc BC and find OX. Let's start with the measure of arc BC, okay? The measure of arc BC equals it's 1/2 the measure of arc CD. Okay, that's from the theorem I just gave you. So it means the measure of arc BC equals 1/2 times 134. Or you can just write 134 divided by 2. And either way you do that, you should get 67 degrees. And remember how you write that. Measure, little m, arc BC equals 67 degrees. Okay. And now we're going to find OX. This one's a little trickier. Okay, let's go and let's label some things. We know that CO, the radius, is 13. Let's label that. This is 13. And you know that chord CD is 24, and you should know that it's bisected, so this is 12. And that's 12. This is the right angle right here. So now what we're going to do is we're going to focus on this triangle. Just focus on that triangle. And here's what I'm going to do. I'm going to use the Pythagorean theorem to find OX, unless you have that Pythagorean triple memorized. But we're going to do OX squared plus 12 squared equals 13 squared. You might have this answer memorized. If not, you're going to have to do out the work to find OX. So OX squared plus 144 equals 169. OX squared equals 25. Square root. You only want the positive one. We don't want a negative distance. OX equals 5. And that's the answer. If you have the Pythagorean triple 5, 12, 13 memorized, you don't have to do the Pythagorean theorem. You say OX is 5 right away. Here we go. Example 5, find the value of X. So we have a radius that's perpendicular to a chord. So it means it bisects the chord. So if this part of the chord is 10.8, then this part is also going to be 10.8. Now, X is not pointing to the entire radius. Okay, in case that's ever not clear, X is just the bottom part. Okay, so here's what I'm going to do. I'll call this part Y. I'm going to use the Pythagorean theorem to solve for Y, and then I'll find X. Okay, so let's use the Pythagorean theorem to solve for Y, because remember, this is the right angle also. So I'm going to do Y squared plus 10.8 squared equals 11.8 squared. Okay. 10.8 squared. Don't round until the end. Put everything out now. So 116.64. Don't round in the middle, because if you round in the middle and then you round at the end, it's too much rounding. 11.8 squared is 139.24. Okay. Now what you're going to do is you're going to subtract, of course. So you're going to get y squared equals 22.6. Y equals the square root of 22.6. You know what I'm doing? I'm going to put out I'm just going to write everything for right now. I'll round at the end. 4.75394573. Now that's y, that's great, but that's not the final answer. Okay. Okay, so like I said, we have y, but you need x. So it might be a little tricky how to get that, but it's really not that bad. Okay. So here's how we're going to do it. Notice. Look at this radius right there. That's a radius, right? Goes from the center to a circle. And then look at this other radius. I'm going to color them both in blue. Those are the same, right? Because all the radii are congruent. All the radii are congruent. That's the definition of a circle. So you should know that x plus y equals 11.8. You should know that. All the radii are congruent. So if you know if you know y, you can easily get x. So I'm going to say x plus y, which is 4.75394.573 equals 11.8. You're going to subtract. Again, you can round to the very end. It doesn't tell you where to round, so I'm going to say x is approximately, I'll do 7.05. It does not tell you where to round. I'll just do 7.05. That looks good. Okay. Last page. In a circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay? So again, look at example 6. We have two chords, VW and ZW. They are equidistant from the center. They're the same distance from the center. They're both 8 away from the center. Therefore, it means they're congruent. So VW is congruent to YZ. Those two chords are congruent because they're the same distance away from the center. It means that they're equal. So VW equals YZ. Set them equal and solve. Subtract 4x. Subtract 6. X equals 7. Question says find VW, so let's do that. VW equals 2x plus 6. So 2 times 7 plus 6 will be 20. Again, it doesn't hurt to do a quick double check. Let's see if YZ is also 20. 4 times x, 4 times 7 is 28, minus 8 equals 20. Good, it's the same. Okay. And one more example to finish it off, example 7. Chords AC and DF are equidistant from the center. Okay. So it means that they're congruent. AC is congruent to DF, okay? That should be clear right away based on the theorem at the top of this page. Those two chords are congruent because they're both 10 away from the center. Okay, let's see one more thing. Here we go. If the radius of circle G is 26, let's just label that. The radius is 26. Let's label that right there, 26. Find AC and find DE. Okay, so here's what we're going to do. And if you look, these triangles are drawn in so that we have a right angle right here. Okay. So they were drawn in that way, okay? So that's a right angle right there. I'm going to call this X, and I'm going to solve for X using the Pythagorean theorem. Okay? So I'm going to do X squared plus 10 squared equals 26 squared. Let's solve for X. X squared plus 100. 26 squared is 676. Subtract 100. X squared equals 576. And then take the square root of that in your calculator, and you're going to see it comes to exactly 24, which is awesome. Okay. So, think back to earlier in this lesson. Since this is perpendicular, it means that the chord is bisected. Okay. So what that means is, since GB is perpendicular to chord AC, it means that this half is congruent to that half. And remember, the two chords are congruent to begin with. So this is also congruent to that. So the final answer, find AC. Well, AC equals AB plus BC. So it equals 24 plus 24, which is 48. Okay. Find AC and then find DE. DE equals 24. Because remember, this chord is also 48 and it's bisected, so 24 and 24. Just like these are 24 and 24. Okay. So make sure you know those theorems from this lesson. And that's the end of it. That was the third lesson in the unit on circles. This lesson was called arcs and chords.